All right, class. So we're going to do our first example of related rates applications on page 63 of your note packet. I cannot project this up on the wall, right? So, but I want you to see, right, the problem that we're going to be doing, right? Example 1 under related rates, okay? So let's read through it. It says the manufacturer of flash drives is willing to make X thousand flash drives available in stores each week when the wholesale price is P dollars per drive. It is known that the relationship between X and P is given by the supply equation X squared minus 3XP plus P squared equals 5, right? So here's where I got the supply equation right here, okay? How fast is the supply of drives changing? Now, you know whenever you have the question, how fast is something changing, that requires a derivative, okay? How fast is the supply of drives changing when the price per drive is $11, the quantity supplied is 4,000 drives, and the wholesale price per drive is increasing at a rate of 10 cents per drive each week. So you're given a rate, well, a rate is a derivative, okay? So that increase in the rate of 10 cents per drive each week, right, is a derivative. So let's define the variables in this problem. X is the quantity supplied in thousands. P is the price of each unit in dollars. And T is time measured in weeks, okay? And so we're asked to find how fast is the supply of drives changing. So it's talking about a quantity, right? How fast is the quantity changing, okay? So we got to find the derivative of X with respect to T, okay? That tells us dx over dt tells us how fast the quantity is changing, okay, with respect to time. And we got to find dx over dt when the quantity is 4,000 and the price is $11 per unit. Now, so if you plug in 4 in for X in the supply equation and 11 in for P in the supply equation and do the arithmetic, you'll see that the left-hand side equals 5. So that combination of X and P, right? 4 for X, 11 for P, satisfies the supply equation, okay? And we're given, okay, that the wholesale price per drive, the price per drive is increasing at a rate of 10 cents per drive each week. So we're given how fast the price of each drive is increasing, right? The price of drives is increasing per week. It's increasing at the rate of 10 cents per drive per week, okay? All right, so we know X, we know P, we know dP over dt. We got to figure out dx over dt. So to figure that out, we have to do implicit differentiation. So here's our supply equation, and we have to differentiate both sides with respect to time, because we're finding the derivative of X with respect to time. And so we got to use implicit differentiation. So we got 1, 2, 3 terms on the left-hand side. So we differentiate each term, right, with respect to time. Well, the derivative of X squared with respect to time, right, bring the 2 down front, subtract 1 from the exponent, you get 2x. But we're differentiating with respect to time, so by the chain rule, we got to multiply that by dx over dt. Next, we differentiate minus 3xp with respect to time. Well, this is a product of two functions, right? X is a function of time, P is a function of time. So we have to use the product rule. Minus 3x is the first function, P is the second. And the form of the product rule we've been using this semester is, right, derivative of the first function times the second, plus the derivative of the second function times the first. Well, the derivative of minus 3x with respect to time, we carry the minus 3, and then we multiply that by the derivative of x with respect to time, which is dx over dt, and then we multiply that by the second function p. Then we add to that the derivative of the second function. Well, P is the second function. Derivative of P with respect to time is dP over dt, and then we multiply that by the first function, which is minus 3x. And then we got to add to that the derivative of P squared with respect to time. Well, by the chain rule, right, you bring the 2 down front, subtract 1 from the exponent, you have 2p, but since we're differentiating with respect to time, we have to multiply that by dp over dt, okay? So this is all implicit differentiation that we've already done. And then on the right-hand side, you know, derivative constant is always 0, okay? Now we have the derivative of the supply equation with respect to time. Now, we don't have to simplify like we did with implicit differentiation because we're just solving for dx over dt. So we're going to plug in for x, we're going to plug in for p, and we're going to plug in for dp over dt, and then solve for dx over dt. So x is 4, p is 11, dp over dt is 0.1, and x is 4 again, p is 11, and dp over dt is 0.1. Okay? Now the reason we use 0.1 for dp over dt, derivative price respect to time, is that's how you write 10 cents in dollars, right? The price is going up 10 cents per week, but we write in dollars, we write 10 cents as 0.10. Okay? So now I've substituted in for xp and dp over dt, and now I got to simplify. 2 times 4 is 8, minus 3 times 11 is minus 33, 0.1 times minus 3 times 4 is minus 1.2, and 2 times 11 times 0.1 is 2.2. Okay? And now I got to do a little more erasing here. We're almost there. So in solving for dx over dt, right, we have 8 dx over dt minus 33 times dx over dt, right? 8 apples minus 33 apples is equal to minus 25 apples. So that simplifies to minus 25 times dx over dt. And then minus 1.2 plus 2.2 is plus 1. So I subtract 1 from both sides, and I get minus 25 times dx over dt is equal to negative 1. Okay? And now, right, I have minus 25 times dx over dt. What undoes multiplication? Division. So we divide both sides by minus 25. And we end up with the derivative of x with respect to time, dx over dt, is equal to 1/25, right? Negative over negative is positive. Well, 1/25 can be written as 0.04, but the derivative of x with respect to time is a rate of change, right? It's just like the speed, a velocity. It's got to have units. And the units are something per something else. Well, remember x is in thousands, so this is 0.04 thousand. 0.04 thousand what? Drives. Right? Flash drives, right? 0.04 thousand flash drives per what unit at time? Weeks. Per week. Time is in weeks. So the rate of change of the quantity supplied, with respect to time, is 0.04 thousand drives per week. And if I multiply 0.04 times 1,000, I get 40. So the rate of change can be written as 40 drives per week. Okay. And we're done. Okay? That's how fast the supply of drives is changing when the price per drive is $11, the quantity supplied is 4,000 drives, and the wholesale price per drive is increasing at the rate of 10 cents per drive each week.